computer. So we refer to these two special triangles and SOHCAHTOA, and you should be able to do all of these. You may just have problems with fractions at times. So sine 45 is, sine is OH, sine is opposite, so opposite on hypotenuse. So that would be 1 on root 2. And if you like, 1 on root 2 can be changed to be multiplying by root 2, top and bottom. And this will rationalize the denominator. So you'll get root 2 on 2. So you could change that to root 2 on 2, which may be nicer at the end. So let's make that root 2 on 2. Cos 60. Cos is car, C-A-H. 60 is here, adjacent on hypotenuse. So that would be 1 on 2. Okay, plus tan 45. For tan is TOA, T-O-A, opposite on adjacent. If you use this angle here, this one, you'll get the same answer, 1 on 1. So TOA is 1 on 1, which is going to be 1. So remember, we need to multiply before we add. So you're going to get root 2 times 1, which is root 2. 2 times 2 is 4, plus 1. So we want to make this into one fraction. So we can do that by multiplying the 1 by 4 on 4. Because 4 on 4 is 1, isn't it? So 1 remains 1. It looks different, but it's the same number. So then we will add those two parts. So we'll have root 2 on 4 plus 4 on 4. And now you have a common denominator. That's the whole idea. We want to get these two numbers to be the same. And if it's a root, then we really should do this here to get rid of the root at the start, if possible. So do this if possible at the start. So then we're going to get root 2 plus 4 on 4. And that will be your final answer. So if you like, you can put this into your calculator and check this here. There's nothing else can be done with that. Okay, we have a common denominator 4 here and root 2 plus 4, which can't be simplified anymore. Right? So how about question 2? Question 16b. So I'll leave that there, but we always refer to these two triangles here. So why don't you try this one yourself for a minute? Now this 2 here means tan 60 squared. So just to be clear on that, why we put the 2 here, what you're actually doing is that, okay, we take tan 60, we find tan 60, and then we square that number. The reason why they put it here is, among other things, I think, is to not get confused and square the angle. So some students might think that's 60 times 60, but it's not. It doesn't mean that. So it's tan 60 times tan 60, okay? So you try that one for a minute and I'll wait to see what you could do. So try it without a calculator. I'll do it in a few minutes. Sorry. Trying to pause the video. So for this question, if you want to avoid confusion, you can rewrite this as 1 minus tan 60 degrees squared. So take tan 60, and tan is TOA. So T-O root 3 on 1, which is root 3, okay? So 1 minus root 3 squared. Okay, so root 3 squared is root 9, which is 3. So remember, in these cases, the square and the square root are inverses, so they cancel each other. So 1 minus 3 is minus 2, negative 2. So you should get that for the answer. So for question C, we have tan 45. Tan is toa. So we should write our rule, so car toa. So toa, tan, T-O-A, 1 on 1 is 1, so easy for the top line. We've got 1. But in the bottom, there's a bit of work. Sine 30, sine is so, S-O-H, so opposite on hypotenuse from this one. So that would be a half. So sine 30 is a half, plus cos 60 adjacent on hypotenuse, a half again. That easy. So that's one thing you'll notice. We'll actually generate some rules later on. So for example, sine 60 is equal to cos 30. And likewise, cos 60 is equal to sine 30. And we'll talk about this a little bit later when we get to this rule here. So you're going to have 1 on a half plus a half, which is 1, isn't it? Half plus half is 1. 1 on 1 is 1. So that's your final answer for that one. Okay, let's come down to the next one a bit. So I'll keep my picture in mind. I never bother to try and remember all these ratios. I just draw the 2 pictures and refer back to the pictures. But if you practice a lot, then you'll probably just remember the ratios, which is good. So sine 30 squared times cos 45 squared. So let's do this bit first. So sine 30 is so S-O-H, which is going to be a half. And then we square that, okay? So we'll get a quarter later. Cos 45 is 1 on root 2 squared. Okay, plus 4 times tan 30. Tan 30 is T-O-A, that's 1 on root 3 squared. Minus 2 cos 90. Now remember the 2 graphs that I drew for you? So cos 90, let's think about the cos graph, because now we have a boundary angle. 90 is called a boundary angle, and we can't form triangles like this when we need to get cos 90. So I prefer the wave diagram. So we have 1 here, negative 1 down here, and remember I mentioned that cos starts at 1 here. So we go 90, 180, 270, 360. So this is the way that I remember these if I don't have a calculator. So this is 360. This first point is 90. This is 180. This point is 270. So this is another diagram you should learn to draw. The key here is cos of the angle. This is cos theta. Will always start at 1. So here we want cos 90. So cos 90, according to this diagram, is 0 on the axis. So this is going to become 0. So we'll put 0 in here, plus 1 on 24, just a fraction. So now we try to simplify this. You can, I know most of you probably use calculator, but just watch and understand. So a half times a half is a quarter, plus 1 squared is 1. Root 2 times root 2 is root 4, which is 2. So root 2 squared is 2. Now this will be 4 times 1 squared is 1. Root 3 squared is 3. Okay. Minus 2 times 0 is gone. Plus 1 on 24. Okay, so we got a quarter plus a half plus 4 on 3 plus 1 on 24. Now, again, without a calculator, go back to grade 6 and think, how do you add fractions? So multiplying fraction, dividing fraction is actually quite easy, but adding and subtracting are harder because you want a common denominator. And you notice your largest denominator is 24. So each of these numbers can be converted to 24, can't they? Each number. So if you want to make 4 into 24, it would be times 8, wouldn't it? So 8, 8, 2 would have to be multiplied by 12, 12. 3 would be 8, 8. You see what I'm doing? I'm just trying to make a common denominator. I think we'll leave E because it's quite long. We'll do a simpler one. So, okay, 8 one's 8. That's going to be incorrect. That's going to be 3. So always look for errors. 3, 3, 3, no, 6, 6. God damn it. All right, 6 times 6 on 6. So 6 ones are 6, 6 fours are 24, 1 12's 12, 2 12's 24. And that's going to be, yeah, 3 8's are 24. 4 8's are 32, and 1 on 24. So at this point, you'll grab your calculator because you want to add the numerators. So we've got 6 plus 12 plus 32 plus 1, 51 on 24. So if we divide that by 24, we end up with 17 on 8. And you can leave it as a improper fraction, that's okay. I'm not sure what is in the answer key there for that one. So in question 18, we got tan beta is 4 on 3. Beta is here, we make a right angle triangle. And we know that tan beta would be TOA, T-O-A, opposite on adjacent. So this would be the opposite side. This is the adjacent side, written as a nice mixed number, nice improper fraction, so easy to work it out. So opposite is 4, adjacent is 3. Now we need Pythagoras to find this length because we have to find sine and cos. So generally speaking, you're going to need to find this side. So we'll have 3 squared plus 4 squared is, let's call that x squared. So we'll have 9 plus 16 equals x squared. X squared is 25. X will equal 5, not the negative root, the positive root. So this is going to be equal to 5 now. That's actually a standard Pythagorean triad. So 3, 4, 5, that's a typical triad you can see. Okay, so sine beta then. So we know sine is so, S-O-H. So opposite on hypotenuse, 4 on 5. Okay, so that's your answer, 4 on 5. Cos beta will be car, C-A-H, adjacent on hypotenuse. So 3 on 5. Finished. Simple as that. But the key is to draw your diagram and label the sides you know, because you'll usually be given this fraction. And you can put beta either here or where I put it. Then you calculate the other side by Pythagoras if you need to, and then you can solve the problem. Okay, so these ones rely on you drawing a picture or at least visualizing it in your mind. Okay, so for question 19, we have the diagram drawn and filled out. Cos theta is adjacent to hypotenuse. So we use the number from the question and fill those two numbers in on the side in the appropriate area, in the appropriate place. And then we use Pythagoras to calculate this number, actually, calculate the 4 if you need to. And then we see we have sec, cosec, and cot. So I wrote the rules out here for those. So that's the basic information that you need. And the rest of it will come from the diagram. So in this question, we're going to have 2 on tan theta. So we refer to our diagram, and tan is TOA, T-O-A, so 4 on 3. Okay, 4 on 3. Minus cot, which is 1 on tan. So if tan is 4 on 3, cot is 3 on 4. They are reciprocals. So I don't even need to really use my rule, do I? So cot is the inverse, the reciprocal of tan. So we'll write 3 on 4 here. 3 sec. Sec is 1 on cos. And we know cos already. So sec is going to be 5 on 3, the reciprocal. You can refer to the diagram if you want and the formula here, these rules, but actually not really necessary. We just find the reciprocal. Minus cosec. Cosec is 1 on sine. So we need the reciprocal of sine. So what was sine theta? Sine is opposite on hypotenuse, 4 on 5, okay? So cosec is going to be 5 on 4. So now we're going to write 5 on 4 here. Okay, so all the numbers are filled in and we just need to calculate them. So 2 4s are 8 on 3 minus 3 on 4. 15 on 3 minus 5 on 4. So don't start cancelling anything here. It looks like I would try to get common denominators in the top then in the bottom. So it's looking like we've got 3 and 4, so we can convert this to 12, can't we? So 12, 12, 12, sorry, 12 would be the common denominator. So this would be multiplied by 3, sorry. 3, and this one would be 4. This is 3 4s are 12, so this will be 3, 3. This is 3, so this would be 4, 4, like that. So we're going to get 4 8s of 32 on 12 minus 9 on 12 on 4 15, 60 on 12 minus 15 on 12. You see, all without a calculator. I know you'll probably want to use a calculator. It's very tempting when you've got fractions like this. So now we have a common denominator 12, and this is 32 minus 9. And this common denominator is also 12. And now we've got 60 minus 15. So 32 minus 9. Well, 32 minus 10 would be 22. So it's 1 less than that. So this would be 23 on 12. 60 minus 15, that would be 45 on 12. Now, in this case, the shortcut is to cancel the 12. So when you divide by a fraction, they will flip over. You'll find the reciprocal. And when you do that, this 12 would actually cancel this one. So cancel the denominators because they're equal. So you'll get 23 on 45 for your final answer. But if you want to look why I cancelled the 12, you'd have 23 on 12 divided by 45 on 12. But when you change this to multiply, this fraction will flip over. So 23 on 12 times 12 on 45. You see, now the 12 will cancel to give you that answer.